So I want to finish up the last two examples here. So I'm going to start with sine. Let me go ahead and get this labeled. I'll double check that I'm actually in radians this time. 2 pi halves and 2 pi. All right, so start with my parent function, get that graphed in there. So I have something to follow. Okay, so then I'll look at each point. Now, my x is being affected here. Now, you also want to have an idea of what this means. What this means is you get 2 cycles in your normal period. So the normal period for sine is 2 pi, right? That would be like my normal period. So to find the new period, we take 2 pi and divide it by b. So the period for this is just pi, right? This 2 also represents how many cycles. So that means between 0 and 2 pi, instead of there just being 1 cycle of sine, there's going to be 2. So it's squished together. That's why this right here is our horizontal compression. So we take the x value and we divide it by 2. Then the negative sign represents a reflection in the x-axis, and our this 2 is our amplitude, or our it's your vertical stretch, but it's an amplitude. Now I'm not shifting up or down any, which means my amplitude it goes from 1 to 2, so it's going to double to be about right there. But I also have to make sure that I'm reflecting. So we can take this a point at a time. I'm going to start at 0. So the first thing I do, my x does get affected. Remember, x lies, so I'm actually dividing by 2, not multiplying by 2. But 0 multiplied or divided by 2 is still 0. And then I multiply that by 2, and I still get 0. Then I reflect it in the x-axis, and guess what? I still get 0. So there's my point for that one. This right here, I'm at pi halves, right? My x value gets divided by 2, which is going to bring me to pi fourths. Then my y value, because of this, gets doubled, so I'm at 1. That brings me to 2. But then it's a reflection in the x-axis, so it comes down here. So then at this point here, my x value is at pi. I'm going to divide that by 2. That brings me to pi halves. My y value is 0, so when I multiply and do everything else, I'm here at 0. If you understand the cycle and everything else, you're pretty much, just by getting this, you should be able to figure out the rest of it. I mean, I'm going to take you through the next 2 points, but at the same time, kind of understand the symmetry and what's happening with sine. So we'll look at this one right here. We've got 3 pi halves, right? And so my x value gets divided by 2, right? So when I divide that by 2, I get 3 pi fourths, because dividing by 2 is the same as multiplying by 1/2. So my 3 pi fourths is going to give me in between right here. So my x value gets right here, plus you can kind of see what's happening on the graph, that's halfway. And it gets divided by 2, and then I'm multiplying it by 2, so I'm at a -1, so that gives me -2, but then there's a reflection in the x-axis, and I'm up here. Then this last point, I'm at 2 pi. My x value gets divided by 2, that gets me to pi. That's 0 times 2, and reflected is still at 0. So you can see how, just by getting this part in there, oh man. All right, just by getting that part in there, that I get, it's the sine shape, but it has been compressed so that my period is just pi, and I'm going to end up with 2 cycles in my normal period of 2 pi. So then I'm just going to, this pattern just continues. This is going to come down, and I'm going to get this point here, and then it looks like these are all at 0 right there. And then you just alternate from up and down. Up, and up. Down here. And there you go. So you can see the compression there and how you have more cycles. All right, now let's look at this one. We are using x again, so I'm still in radians. So I'll make this pi halves, this at pi, just pi, this 3 pi halves, and this 2 pi. All right, so then I'm going to put in my parent function, and that's going to look like this. This is my asymptote. And I kind of wish that I was able to really use just pencil and a color, because I think with tangent, all this overlapping makes it a little confusing. But I can't really do mine lighter than what normal is, like I could if it's a pencil. This, remember, this is negative here, positive here. So this is one cycle of my parent graph. Then I'm going to figure out what's happening with this. Now my x value is being affected again, but I am not, it's not a compression or a stretch. Instead, it is a translation. So I'm moving over pi halves, but I'm moving to the left pi halves. Okay, so if I start here with my asymptote, I'm at pi halves. When my asymptote moves over to the left pi halves, it ends up right here on the axis. And then the rest, since that's an asymptote, doesn't really matter. So then I'm going to go to this point right here. So I'm going to move it over pi halves, which means it moves over to here. Then my y value gets multiplied by 2, so it becomes negative 2. And it gets reflected in the x-axis, so it ends up here. This value here is at pi. The x value is at pi. I shift it to the left pi halves. And then I multiply and reflect, and since it's on the x-axis, nothing happens. Then this point here, I translate it left pi halves. My y value is 1. I multiply it by 2, but then I reflect it in the x-axis to get that right there. And then my asymptote is at 3 pi halves. It moves over to pi halves, like this. And then this is my translated graph. Remember, this is not an amplitude. Here, my amplitude is 2. So you can see you got a distance of 2 right here. I cannot measure this distance. So it's still an A value. It's a vertical stretch, but it is not an amplitude. So now my purple graph is my new graph. My green one is my parent graph. So now I just have to repeat this since it's a periodic function. And I see that I go, my period is still pi. So for every pi there, I'm going to have an asymptote. Pi, I get an asymptote. And then in between the middle of those two asymptotes, I get a point. Then a point here, here, use that one, here, and here, which means over here there's one down here. So these look like this, with my arrows on them. There you go. All right, so my period here is still just pi. Okay. There is no amplitude. There's only one cycle per normal period there. And I shifted it to the left. Shifted it, reflected it, and stretched it. Okay. Hopefully those two examples help.